So good evening, ladies and gentlemen. I am Prasanna Naranguda, the Chairman of Building Services Engineering Sectional Committee of ISL. So today we are going to do a very important public lecture with very timely important topic, which is the role of IoT in IR4 world. The role of IoT in IR4 world. I'm sure that you will be definitely beneficial out of this presentation and its content, basically, which will be shared by two eminent presenters, Engineer Chatra Peris and Engineer Chamila Vijayawardena. So we will start the session very soon. I want to give you a very small message before that. There is one message is to keep your mic mute mode. Kindly keep your mic, all mics mute mode. And at the end of the presentation, you will be getting a chance to open the mic and ask questions if you have. Or unless you can put your questions into the chat box so that our moderator will note all these the questions and arrange them and finally forward to the presenter or the speaker at the end of the presentation. So today's presentation will be shared by two engineers, Engineer Chatra Peris and Engineer Chamila Vijayawardena. So we are very thankful for both of them, Engineer Chatura and Engineer Chamila, accepting our invitation, very short invitation, and preparing the presentations, and willingly coming forward to share your knowledge and experience with our engineers of ISL, and also all the technical people who are in the industry. I am sure the audience will be definitely getting beneficial out of this. So I would like to invite Engineer Kaushal Patirana to give the introduction about two speakers today. Engineer Kaushal, please.
Thank you very much, Engineer Naranguda. Good evening, ladies and gentlemen. I am Engineer Kaushal Patirana from Building Service Engineering Sectional Committee. I warmly welcome you all to the second webinar organized by the Building Service Engineering Sectional Committee for the session 2020 and 21. The webinar will be in two sessions and will be conducted by two well-qualified engineers. Thank you all for joining with us today, and let me introduce our speakers today. Our first speaker, Engineer Chatra Peris, graduated with honors as an electronic and telecommunication engineer from University of Moratuwa. He also holds a master's in telecommunication engineering from University of Moratuwa and postgraduate diploma in management accounting from Chartered Institute of Management Accountants. Engineer Chatura heads the product and services innovation function of Dialog Axiata PLC. His portfolio spans in emerging technology research and development. He has more than 17 years of diverse experience in this field. Engineer Chatura has contributed actively as an architect in many private and public sector digitalization initiatives. Our second session will be done by Engineer Chamila Vijayawardena. Engineer Chamila Vijayawardena graduated with honors as an electronic and telecommunication engineer from University of Moratuwa and possesses an MBA from PMI, University of Sri Jayawardenapura. He started his career as a SAP consultant. Engineer Chamila has over 16 years of experience in information and communication technologies, which spans across many forms of technologies as well as Internet of Things. As a member of the new product development and the R&D team of Dialog Axiata, Engineer Chamila has addressed a number of corporate and industrial forums on different technology topics and currently works as an associate architect for the product and service innovation division of Dialog Axiata PLC. We warmly welcome Engineer Chamila for this forum. Ladies and gentlemen, without further ado, please join with me to welcome our speakers tonight, Engineer Chatra Peris and Engineer Chamila Vijayawardena. And one other thing, I would like to remind you that there will be a Q&A session at the end of presentation, and you can post your questions to the moderator through a chat during the presentation, and we will direct your question to the speaker at the end of the presentation. Now let's move on to the presentation. Over to you, Engineer Chatura Pires.
Okay, so let's start the presentation. So basically, today's topic is role of IoT in an IR 4.0 world. So first of all, uh, I may give a kind of a glimpse of introduction in terms of what are the areas that we are planning to cover during this 1 hour lecture. So basically, the presentation is divided into 4 segments. First, I will give a kind of introduction to IR 4.0, and then how this IoT enables this IR 4.0 from an holistic standpoint. And then we will touch base with this architecture blueprint. And then I will hand over the session to my colleague Chamila, who will cover this emerging market IoT applications and the future of IoT. So with that, let's start with the first section. First of all, let me start my presentation with a quick glimpse of introduction to this industrial revolutions. As we all know, this industry 1.0 is mainly focusing on mechanization. And then it got evolved to mass production and electrification. And with the evolution of industrial revolution 3.0, we got this compute and automation as key enablers. And now we are in an era of industrial revolution 4.0. We call it as IR 4.0 in short form. And the focus is mainly on cyber physical systems. So let's have a quick deep dive in terms of what is this cyber physical systems mean. So as we all know, cyber means the internet. In general, stuff available in the information world, basically data, software, and whatever the application. And we all know what is physical systems means, all the stuff that is around us. So cyber physical systems are integration of computation, networking, physical processors which sense, network, and control these physical objects. These cyber physical systems are powered by a plethora of technology enablers, as you can see below: Internet of Things, artificial intelligence, big data, computer vision, robotics, blockchain, extended reality, and even drone technology. In an IR 4.0 world, the technology defines the industry competitiveness. It endangers a divide between adopters and laggards. So those who embrace these technological advancements very quickly and embrace these technologies into their day-to-day working practices and productization will elevate productivity and competitiveness and gather market share largely. Whereas those who lags in terms of adaptation will lose the market share, as well as they will reduce their competitive advantage. So from another angle, these digital trends of IR 4.0 has enforced reinvention triggers. So all these reinvention triggers are mainly centered on 4 different pillars. First thing is technology dynamics. I think in my previous slide, I've captured this, what are these IR 4.0 technologies in high level. And all because of these IR 4.0 enabled technologies, there was a kind of a vast array of new use cases and new consumer requirements, new consumer perceptions. Hence, the consumers also got evolved. And due to these technology enhancements and the consumer evolution, there were a lot of disruptive innovations boomed up. And altogether, all these 3 factors has contributed dramatically in terms of transforming the entire value chain. So from an industry standpoint, we must get all our senses on in terms of focusing on signals of change. So what are the signals of change? Those signals are the stuff that I just mentioned: technology dynamics, consumer evolution patterns, disruptive innovations, value chain transformations. And as you can see here, those who fail to sense these in timely fashion today extinct. I think most of you might familiar with these names and the logos. So just to give a glimpse of quick background, I think Blockbuster was one of such entity where they were a kind of a market dominant during 1980s with this VHS cassette and CD rental business where they had physical stores. But they failed to compete with streaming and mailing platforms such as Netflix. So meaning that they lost the signals of change with the upcoming boom of internet. And unfortunately, they lost their entire market share and went bankruptcy during 2010. And also Kodak also underwent a kind of a similar issue where they were the first to introduce a digital camera. However, they kept it in a black box, assuming that their films and paper industry was very profitable at that time, and that might have a negative impact if they introduce digital photography. However, there are competitors like Fujifilm and all identified this as a key opportunity, and then they get the sense at the correct piece of time, and they attack in terms of heavy competitive advantage towards all the other competitors. So the Kodak also got bankrupt during 2012. And Polaroid and Nokia also had similar kind of endeavors. And since Nokia is from telecommunication, I think most of you might have experienced what happened to them because they were starting and they were the having the majority of share in terms of mobile market during the era of feature phone before the smartphones came into the picture. And they had their own operating systems called Symbian. They were very successful during early 2000. So we were having a kind of a pride to own a Nokia phone, if you can remember yourselves those days. But unfortunately, Nokia lost the market share because they failed in terms of signals of change, where Apple and Google identified that open source operating systems such as Android and also the service enabler developer communities so that they have partnered with. Whereas Nokia thought, no, since we are the market leader, our Symbian operating system, we will never expose to any third parties. Unfortunately, they also lost the market because of they failed to embrace these technology trends and the signals of change on time. Hence, to be successful in this IR 4.0 world, the mantra behind the success is we all must focus on power of scale because winner takes it all. So you should not keep anything left for others to compete. So if you look at this potential of IR 4.0 from an emerging market standpoint, because Sri Lanka belongs to emerging market segments, let's analyze the opportunity and threat as well. So technology revolutions provide double-edged implications. Why I'm saying that is at the same time when there's an opportunity because emerging markets help them to catch up in a very high gradient of scale. But at the same time, there's a threat to these emerging markets because it help develop markets to increase lead and dominance. So the engineers like us, our focus should be on securing a digital bridge to catch and then stay ahead where technology plays a major role. So with that, let's focus on our topic, role of IoT in an IR 4.0 world. Why we say IoT is a core central pillar in this IR 4.0. So as you can see in this picture, IR 4.0 is centered as a nerve center for IR 4.0 enablement. Why I am saying that is IoT enables network communication between so-called next generation technology enablers. We call it service enablers. You take it artificial intelligence or machine learning, computer vision, extended reality, big data analytics or robotic, whatever need to communicate, you need to have a communication network, which is provided by Internet of Things. And on the other side, in order to have service orchestration, because of this IR 4.0 service enablement, no such vertical silo-based applications will exist. Whereas all these use cases and all these consumer demands will have next generation service orchestration requirements, meaning that the service enablers like artificial intelligence will orchestrate with a big data kind of a analytical engine, not in silo. So in combination together, it will deliver more in terms of driving these technology-led use cases. And the third capability, which is provided by IoT, is the service exposure. So the services which grabs from the underlying sensors and the actuators will then expose to the developer community so that they can bring next generation use cases, next generation services to the market. So that gives us opportunity, like we are in an emerging market, to play a kind of a major role in this IR4.0 enablement. So with that quick introduction, let's go deep dive into what is Internet of Things. If you look at this slide, you can see there are different logos here. These are the logos from different standardization body. You might be almost familiar if you are a telecommunication or technology engineer, because International Telecommunication Union is the ethics body who defines telecommunication related standards, and also GSMA, 3GPP, IEEE, and W3C likewise. But for today's discussion, I'll be mainly focusing on one specific definition. So as per ITU definition, they define Internet of Things as a global infrastructure for the information society, enabling advanced services by interconnecting physical and virtual things. You must give some prominence to these two keywords. They call it physical and virtual things based on existing and evolving interoperable information and communication technologies. So let's deep dive into this architecture a little bit more. So physical things, as we discussed during the IR4.0 definition also, even IR4.0 was focusing on cyber physical system. So cyber means the information. So the information includes all this virtual stuff which exist in the information world and are capable of being stored and processed and accessed. For example, data, multimedia content, and application software. Whereas physical things, we all know, stuff exists in a physical world and capable of being sensed, actuated, and connected. So the equipment, machines, goods all belongs to that. So what exactly IoT does is, as you can see here, it bridges the cyber world or the information world with the physical world and create a connectivity between a virtual thing and a physical thing. So if I go a little bit down, the physical thing, if you take an example of a machine and with a kind of a sensory devices sending data to a kind of a information cloud, it gives a bridge of connectivity to pass that information. And also it provides device level communication. You can have device to device communication or device to multiple device communication via a communication network or through a gateway hub. So that is the power of IoT, because IoT provides the physical level of access to communicate and transmit data from one device to another device or one device to a virtual world entity, where the data get processed and analyzed and give meaningful insights. So if you want to get more detailed about this particular definitions and specifications, you can almost refer this ITU standards, which is defined as ITUT Y.2060, and you can get full glimpse of how they are defining this entire IoT ecosystem. So with that quick introduction, let me give you a brief history about IoT. So as we all know, this ARPANET was the first anchor point for this internet, and that was introduced during 1969. After that, internet has played a major role in terms of dramatically changing the use cases and lives of humans. And if you go back to 1982, the very first IoT use case emerged from Carnegie Mellon Research Institute, where they had a kind of a pain point. Actually, there was a kind of a requirement because these researchers from this institute, they were located at the second floor of that building, and they had their Coke vending machine at the ground floor. So they used to go down and check what's the temperature of that machine so that they can have this chilled Coke. But one fine day, they had kind of meetings and they haven't had time to go there, and somebody or some OA to send there and ask whether the cans are now in a kind of a state which is chilled or not. So they thought, without sending a human being there, whether can we have some kind of a remote monitoring capability so that we can measure the temperature of a vending machine. So that was the first insight or the first emergence of IoT use case that went far down to 1982. And during 1999, the MIT researcher Kevin Ashton has defined the term Internet of Things. And after 18 years of Carnegie Mellon researchers introduced this IoT first use case during the year 2000, LG has introduced first commercialized smart fridge. And thereafter, this chronological evolution has boosted. And just to name few, Google has introduced autonomous driving vehicles, the concept of that with a rapid prototype during early 2009. And followed by Amazon, they have introduced Amazon Echo, which is a kind of a voice gateway where you can interact with your devices or IoT ecosystem through voice-based communication. And if you move down, you can see different evolution and different variations of IoT. So during these early days of Internet of Things, it was always focusing only on machine-to-machine communication. That is what this M2M stands for. So direct communication between machine to machine without human intervention was the focus at that time. And that was point to point. And the machines needs to be situated maybe at a common physical location, and they may be having kind of wired connectivity, and one machine to another machine, they communicate and pass this data and states of that machine. But then it got evolved in the next phase of evolution to Internet of Things, where it has went above the boundaries of a physical one location and went into a network of devices. So it's IoT is an ecosystem of connected devices, communicates via internet without any human intervention. So the internet was the primary physical anchor to get these devices connected, not only wired connection. Not only stopping from that point, it further evolved to IoE. IoE stands for Internet of Everything. That is bringing together people, processes, and data into this equation. So we will discuss those things in the upcoming slides. And the next evolution is Internet of Behaviors. We call it IOB. This is the buzzword during late 2020 and 2021. So Internet of Behavior collects the digital dust of machines and people's interactions from a variety of sources and processes them to identify meaningful correlations of behavior patterns. So if you decrypt a little bit, so it takes insights or data from both machines, not only machines, but also from people and their interactions from variety of sources. So from machines that we know that you can put a sensor and get this information. But even for people, if you wear a wearable or something, of course you can take. But going beyond that, with the enablement of IR4.0, even this computer vision kind of algorithms gives the pulse of trigger based on the people patterns and their interactions. You can get where exactly your movements, but where exactly you go, and all these kind of insights also takes as a feed from IoT and give that to data world and do this data analytics. And once you do that data analytics, they identify a meaningful correlation and define a behavior pattern for that. So let's take that from an example. So if you look at the manufacturing context, a kind of a factory with different sort of machines, when you get almost all these details from machines and from people who operate these machines and the processors, you can identify different patterns. So let's say if you monitor the energy, you can analyze the power consumption patterns of that machine. And if you analyze the anomaly behavior based on the machine operating time, and you can alert and notify operators inefficiencies or their different problems of root causes based on the different behavioral analysis of this data. So based on that, let's say, for example, if you identify an abnormal pattern of an energy consumption in a particular motor, it gives a pulse of a trigger on top of IoT that this machine either is having some issue or it is about to malfunction. So likewise, the opportunities are endless. You can identify different behaviors, different analytical algorithms. Through that, you can identify different sort of correlations with the power of IOB. So with that, let me move on to my next session. So during this session, let's discuss in brief a kind of architecture, fundamentals behind this IoT. So if you look at the early stages of IoT, maybe if we take the M2M kind of stage, so we were looking at vertical silo-based use cases. What do you mean by vertical silos? One use case does not have any correlation with any other use case. So let's say, for example, now let's assume that we've deployed a smart surveillance camera or a CCTV system to monitor the security of the citizens. And that smart surveillance camera systems will give feeds to the DVR, and DVR will analyze either on on-prem hardware or on a cloud instance what are these camera feeds are giving. Other than that, it won't do anything else. And if you take another vertical of use case such as smart traffic management, so RDA might have a requirement to monitor and these traffic patterns at different junctions and give a kind of electronic control to this traffic control lighting systems. But in those days, these were operating in isolation. So likewise, even for agri, health, or industry automation, all these use cases were in silo. But in now, with the IR4.0 evolution, it has really evolved. So let me take the same example of this, the surveillance camera system. If we deploy this surveillance camera system nowadays, what you can do is you can do IoT-based service orchestration, meaning that northbound applications can orchestrate between each other to give much additional meaningful information. And at the same time, at the underlying device layer, you can share or pool these devices. So if we take the same example of surveillance system and the traffic management system, instead of having separate two different silo of camera deployed at different locations, you can make use of the same camera which used to get the feeds of surveillance system to give a pulse of a direction to traffic management systems to change the traffic lights. And at the same time, from the surveillance system data, you can predict different set of behaviors or internet of behavior patterns to give a kind of a long-term predictions how these traffic patterns are going to be changed. Hence, the algorithms needs to be optimized in dynamic fashion. So all this on-the-fly decision-making, on-the-fly algorithm optimization, everything was possible because of power of IR4.0 enablers supported by a proper IoT platform. So this proper IoT platform means instead of vertical silos, here we are having a horizontal layered approach. All these layers are interconnected. So we will run through these layers and what exactly their functionalities in the upcoming slides. But just to give you a holistic picture, you can see that all these layers will communicate with each other as well as they orchestrate with different services, even bypassing some of the services as and when required. So all the sensory devices inputs coming from the southbound end will be fed and traverse through all these set of layers and get a kind of a meaningful insight view to the northbound application. So this box gives the full platter of architecture for the IoT technology piece. And at the same time, my colleague Shamila will also touch base how this non-technology stack, which is covering the business model evolution and the social impacts related dynamics in terms of bridging these use cases together with business side insights to create a kind of a dynamic architecture blueprint. So with that, let's go back to our this IoT technology stack. So let's focus on IoT device layer, what exactly the capabilities are. As we discussed or as defined in the IoT definition, it uses physical world sensors to get this data. So sensors, what they does is they get whatever the abstracted information from different machines, and then they pass this information to the next layer. And all the process information then fed back to actuators so that you can remotely control these machines. In order to do this bridging, all these sensors and actuators will occupy a gateway device. There can be sensors which having built-in gateway capability as well. But if you look at the dynamics or the business case for IoT, you need to make sure the cost at very low price points. Hence, that the standards define a common gateway devices so that sensors can have direct communication only with the gateway device, and then gateway device will directly connect through the internet to the IoT full architecture. That is the power of the sensory or the device layer ecosystem in this IR4.0 enablement. So all these sensors can be of any type. It can be utility monitoring for energy or water, or it can be humidity, temperature monitoring, you name it. You can have any platter of sensors and actuators. And all these use cases will be traversed through an IoT gateway and then back to IoT platform. But one point to note, because IoT will give billions of sensors and actuators, but we need to uniquely differentiate and identify these sensors and actuators from somebody else's stuff. So in order to do that, there is a unique ID associated to all these sensors and actuators. In these technology terms, we call it UID, UDI, and these UDIs can, in some cases, will be burnt into the device level from a hardware kind of stuff like a MAC address or kind of any other specific identifier. And also there, in some cases, can be provisioned through a radio subsystem. For example, you can make use of a SIM-enabled device with a MSISD or the mobile number as the unique identifier to differentiate among all the other devices. So that completes a kind of a high-level overview about the device layer. So device layer needs the next layer, which is this IoT communication layer to bridge this, the captured information traverse to the next level. So this includes two types of enablers. One is this communication technology enablers, other side, this IoT protocol stack. So if you look at the communication technology enablers, you might be familiar with most of the terms. You can use any wired connectivity or wireless connectivity. If you take wired, so fiber or Ethernet cables or anything that you can name it in this domain. If you take the wireless piece, you can use any wireless communication technology such as Wi-Fi, Bluetooth, near field communication, RF, or even in nowadays NB-IoT, 5G, 4G, LoRaWAN, so on. But the critical focus when deciding this technology, communication technology or an IoT protocol is centered on three main driving factors. First thing is range of communication. Let's say if you want to have some home automation where you only need to communicate with a device within your perimeter of your home boundaries. So the technologies that you can use will be Wi-Fi or Bluetooth, even RF. But if you are in a kind of a scenario where you need to have your entire, let's say CB or LECO wants to monitor their entire smart metering ecosystem. So then you can't have Wi-Fi as a communication anchor because you need to have long range communication. Hence, the potential will be either 2G or 5G. And the second dimensioning factor is the data rate. Now, let's say the example that we got in the previous slides, the surveillance system. I think the primary factor that you want to do analytical insights in this computer vision layer is to have higher data bandwidth, because otherwise you can't transmit HD or ultra high definition quality data into the backend to do the processing. So if you want such kind of a high data rate, then you need to go with a sufficient communication technologies which supports that kind of data rates, such as 5G or 4G. And third, but not least, or not last, the power consumption is another driving factor in terms of deciding proper technology and the communication protocol. Because most of the use cases now, if you take this water metering scenario, where you won't get any kind of active power source next to this water meter. So those devices will be powered with a small battery. So this communication should support a long range of communication for a long period of time. So the technologies like NB-IoT will be the candidate because you are sending very small amount of data, but over a long period of time. So you don't need to go and replace these batteries very frequently. So those are the dimensioning parameters when you want to decide what is the best technology enabler and the best technology protocol stack which is needed for this IoT enablement. If you look at these protocols, I think these days the first two, the COAP and the MQTT, are the most popular protocol stacks that are used by most of the emerging IoT service providers. So these are kind of publish and subscribe kind of a protocol stack they are using. So similar to what this Facebook use for their messaging, these IoT protocols also using very small amount of data communication, because if you increase the complexity of this protocol, your electronics, the cost of electronics and the complexity of electronics at the edge device gonna be high, which in return increase the cost of the device. Hence, the proper selection of communication enabler as well as the protocol enabler is vital for a successful IoT deployment. With that, next let's move on to the next layer, so which is this service orchestration. This layer comprises of mainly three pillars. First thing is network abstraction layer. So what this abstraction layer does is it abstracts information from underlying devices which traverse through the communication link layer and get these data aggregated at this level. And then these data get cleansed and storage and then provisioned for different applications. So that is where we define that I mentioned that there should be an identifier to differentiate these sensors or actuators. So based on this identifier, which is coming through these sensors or actuators and included, embedded into the IoT protocols such as COAP and MQTT, will get traversed to this data abstraction layer. Through that identifiers, then you can identify which pillar of application that this data should be traversed to, hence the provision. And the middle piece is the service orchestration and analytics layer. So as we mentioned and discussed in high level in my previous slide, the enablers such as artificial intelligence, machine learning, big data analytics, blockchain comes into this space. So the underlying data sets grabbed from the sensors and actuators now fed for service orchestration with these 4IR enablers. And it gives much more value added meaningful insights in terms of driving Internet of Behaviors or IOB kind of a pattern generation application. And once you do that processing and analytical functionality, the IoT service exposure layer will expose these capabilities to the next level of applications. So one side, it will directly communicate with the northbound application. Now in an example which we got earlier for the surveillance camera, the information through high definition video feeds will get analyzed at the service orchestration layer with artificial intelligence and video machine learning based algorithms to identify faces, to identify machines, to identify speeds of vehicle, identify different types of vehicle or consumer behavior patterns, and then feed this information through this application exposure layer to the northbound application. Also, similar to what Google and Apple does, here we can expose these capabilities to other development parties, such as developer communities. So from one side, while we are primarily achieving our use case, if you take even the surveillance system, on the other side, you can give this feed of information to do different orchestration of or different disruptive innovations with startups or any other developer community players. So all these exposed APIs will then feed data to IoT application. So application layer will act as a digital twin. What do you mean by digital twin? Digital twin is another hype in this era of IR 4.0, because especially after this post-COVID opportunities, I think you might have seen in most of the white papers also, most of the developed countries has used these digital twin capabilities to remotely operate some of the machines. So you might have already saw some case studies that China and even US is using this digital twin kind of remote controlling capability to manage their port operations with their overhead cranes, so that the crane operator need not to physically be inside the crane, but they operate the crane through a digital twin. So digital twin gives the full insight without having a physical presence at that physical location. So while you have all these pillars of communication, you must make sure that security also will be enabled at all these different levels of layers. So if you take in a kind of a high level, we need to focus on device level security, connection level or the communication level security, or platform or application level security. If you look at the device level security, you need to focus on hardware level protection or firmware level hardening. So you need to make sure that the devices, the sensed input of these devices will not be accessible by any third party. And even while you are communicating, you need to make sure a kind of a private network, so that even you traverse this information through the public internet, you need to make sure with VPN kind of tunnels to create this private pipe, so anybody else or the intruder can't jump in. And same at the platform layer. So one thing to highlight, we must ensure this data privacy, because now, as we discussed in the IOB slide, the Internet of Behaviors will capture not only machine stuff, but also human behaviors also will be analyzed. So when doing and processing these analytical information, there can be different ethical concerns will pop up. So we might need to safeguard these things with different policy frameworks. So we must focus on national policy for this data privacy. I think maybe most of you are already aware that ICT is already working, and there is a data policy act being formed for covering most of these IoT kind of security related use cases. So those are very vital to make sure our governance and security is to the point. And with that, I will give a quick glimpse of introduction to 5G and show how these 5G networks will leverage the deployment of IoT. So if you look at 5G, 5G stands for fifth generation. So we evolved from 2G, 3G, 4G, and 5G. And you call 5G as air fiber. Why you call air fiber? You can give fiber kind of speeds with a wireless network. The feature of EMBB stands for Enhanced Mobile Broadband. the feature of EMBB can support up to maximum nearly around 1 gigabit per second kind of data rates on your palm top. So meaning that your mobile phone can grab that kind of a data rates in time to. And so the use cases such as this video surveillance or computer vision needs this kind of capability to transmit high resolution and ultra high definition information without lossless communication medium. So this EMBB slice of 5G will enable that kind of IoT and 4IR enablement. And the next pillar is URLCC. URLCC stands for ultra reliable low latency communication. This layer is mainly focusing on applications having stringent latency and reliability requirements. If you look at this example of autonomous driving, you might need to have a lot of algorithms, a lot of sensors communicating with each other. And also the power of 5G gives a kind of platter of capabilities to decouple some of the processing logics from the end device and parking that processing part at the cloud level, at the backend. So in order to do that, you need to have very low latency communication link from that sensory device back to the backend and get the feedback back to the sensory device. So 5G enables less than 5 milliseconds of latency in supporting those vehicle-to-vehicle autonomous driving and industrial automation use cases. And the third slice is MMTC. MMTC stands for Massive Machine Type Communication. If you look at from an example, now the smart metering. So you can imagine the number of smart meters alone that is required to communicate to grid all these water and electricity related information from our house. So the communication network should support mass communication of this massive machine type communication in this OIR world. So that is powered by 5G in this MMTC layer. So all these layers, I use the term slice. So slice means these different network capabilities are built into multiple logical networks when it comes to 5G. Let me explain you with this slide. So you can see the use case that I mentioned earlier with EMBB is to have an ultra high definition video feed communicating to the IoT northbound cloud to identify traffic patterns or any other security related concerns. But at the same time, you can have a massive machine type IoT slice as well as mission critical IoT slice communicating low latency communication without any hindrance due to massive data transfers coming from this slice. If you take 4G or 5G or ADSL or whatever current technologies, you can't do that. Because it's pooled the bandwidth together in terms of giving these services. So you might have experience even in these days when you are working from home, when almost all your neighborhood is working or downloading video, your internet connectivity to collaborate with others with Teams, Microsoft Teams or Zoom will get degraded. But in an era of 5G, it will not happen like that because of due to power of this network slicing. You can give dedicated network slices to support this remote surgeries, remote decision making to support this vehicle-to-vehicle autonomous driving kind of use cases. So even for examples like this manufacturing industry, this AGVs or automated guided vehicles will be booming because even I know that there are a lot of enterprises even currently doing R&D and some of them have already deployed these kind of AGVs in operation, but they need to make a kind of autonomous capability. In order to do that, this 5G together with IR4.0 and IoT will enable a full platter of capabilities in bridging these barriers of communication. So that is the power of 5G. So with that, if you look at a factory in another maybe 2 years down the line, even in Sri Lanka, it is going to be like this. So it's a reconfigurable factory of the future with 5G, AI, IoT, and full mix of IR4.0 enablers. So from one side, you will get the surveillance systems or the CCTV feeds analyzing both visual and sensory inputs coming from the factory from an holistic view. And from other side, that you will get the extended reality kind of guided decision-making capabilities, and you will get this kind of dashboards coming over digital twin. So without these engineers physically going and diagnosing issues at the factory floor level, and robotics will come into the road where the logics will control these robots communicating from the cloud without having physical infrastructure next to the robots, which will reduce the cost of deployment, and it will emerge the penetration of this next generation use case. So if you look at from a kind of a headline point of view, you can get a transformation of time-based preventive maintenance to a condition-based predictive maintenance in time to come. So currently we are having a kind of a timestamp, okay, that we have done the last maintenance during last year, during December. So our next maintenance cycle is going to be next this year, December. But in time to come, these things will going to change with the power of 4IR enablers, because it is going to be condition based, because this internet of behaviors will track the behaviors of these machines and humans, and then it will predict the maintenance cycle. So with that, let me start a quick video to give a kind of an introduction exactly what this 5G has given, and it will give a kind of a reality in this particular domain. This is something that we have actually done with our innovation foundry laboratories, with our own local engineers, and just have a look.
Randy is there and he's doing his hand movements, gestures and everything. And everything is captured by that webcam over there as a video feed. Then we are sending this video feed to a remote cloud server through 5G internet. Then in that cloud server, we are processing everything and creating this virtual skeleton, and we are converting everything into mathematical data. Then again through 5G internet, we are transmitting all of those data to that robot. So that robot can respond to Randy right here and his movements almost instantaneously through 5G. And those are the stuff that we can do with Dialog 5G.
So just to give a glimpse of this thing that you can see here, we are using computer vision. So the video feeds that I mentioned earlier on 5G EMBB slides, we are getting the ultra high definition feeds of that video, and then we have developed a local artificial intelligence and machine learning based algorithm without any sensory inputs, just based on the video footage to track the movements of this person. And in real time, we process this data at our backend and feed to these robots to control in real time. So that is the power of 5G, and that is why I mentioned that emerging markets also can leapfrog and contribute towards these technology revolutions. And definitely with that power of technology, we can move away from this the acronym of developing nation to a developed nation in very soon. So with that, let me hand over my slides to Chamila. Thank you very much. Chamila, over to you.
Yeah, thank you, Chaturu. Let me upload my presentation. I hope everyone can see it in this section. I will be talking about IoT applications and then subsequently the challenges we face in implementing these applications and what kind of a future we would be having with IoT. So I would cover these points. Let's quickly look at the different IoT application types. As you can see in this screen, largely it can be divided into two main categories: consumer IoT and industrial IoT. Consumer IoT is your personal IoT devices like your smart TVs, your voice assistant devices like Google Homes and Alexas, and your wearables like Fitbits, and then any healthcare band you are wearing, connected cars like that from Tesla and so on. And on the industrial IoT side, it is more serious applications like asset management, predictive maintenance, worker safety, environment monitoring, energy management. So this is not a hard and fast divider. If you take energy management, you can use the same energy monitoring device to monitor your home's energy as well. But this is a fundamental demarcation of different IoT applications, and if you see the fundamental difference here, in the consumer IoT side, it is more or less the consumer electronics companies that dominate. The Samsungs, the Apples, Sonys, and Huawei's of the world. Because even if you have innovative companies here, there is a tendency, a long-term tendency for these large companies to crowd out or swallow these smaller companies. For example, you might probably know that now that Fitbit belongs to Google, and once there was this another similar company called Jawbone, and that company is no longer there. And recently, HTC has stopped manufacturing their mobile devices, and LG is considering stop making their mobile devices. Likewise, so large players dominate this consumer IoT segment. And the one interesting fact I want to highlight here is now there is this recent article on New York Times on why your TV spies on you. Spying in this sense means that it collects information as to the programs you watch. And what they do is they share these with advertising companies, and then those information is being used to sell us cars, credit cards, and so on. So the point made here is that it's more lucrative to sell personal information than to sell TV sets. So that is what IoT has enabled for these consumer electronics companies. Similarly, it's similarly the case with Fitbit, because it's no longer a company that sells you wearables. It will come from your corporate, and it will say that the device they'll sell to your corporate, saying it can improve your health, monitor the employee's health, and maybe in another sense from an insurance context, monitor your health and give you suitable health insurance packages. So IoT has in a way enabled these consumer electronics companies to pivot their business model. So it's no longer selling of smart TVs, but selling of information kind of a thing. So I'll touch more on these business models in the subsequent slides as well. Industrial IoT, on the other hand, is a different animal, because there you can create your own applications. As Chatura mentioned, there are different layers, and you can choose your own sensors, your own actuators, you can choose your own network, and then you can choose any of the platforms. You can develop your own platform, or take someone from AWS or Google, whatever you want. And then you can develop your own IoT application, or you can take one of the off-the-shelf cloud applications. Likewise, it's more or less an engineer's playing field where you have more room to play in. And I'll be talking more about these industrial applications going forward. Moving on to the next slide, before talking about the industrial IoT applications from a Sri Lankan context, let us go through some statistics for Sri Lanka, because I'll give you some statistics on the demography and our food ratio and the diseases affecting us. If you look at our demographic trends, our population has been increasing, but it's growing at a slower rate, less than 1%. So what it means is it will peak around in 2039 to about 2.19 million people. And then at around 2100, it will be around 50 million people. This is based on UN predictions. And the implications are we will have one of the largest growing elderly populations in the world. And our working age population will also decline as a result. So now you know how it is difficult to find people to do certain things. So it's not going to be easier. It's going to be very much difficult. And then if you look at our food ratio is from your income, what is the percentage that you spend on food. In the early 1980s, it's around 65% for the entire Sri Lanka. But now in 2012, it's around 38%. So what it has meant is our mean household incomes have increased over a period of time. And then our consumption patterns have also changed, because the carbohydrates in our diets have decreased and proteins have increased. Means that we have more fish, egg, and meat in our diets, right? So as a result, we are having these diseases as well. So if you look at Sri Lanka, 75% of the people die from non-communicable diseases like the heart diseases, the diabetes, the high blood pressures, and so on, right? So there are some damning statistics from the the World Health Organization as well. So you might wonder why this has to do with IoT and an IoT presentation, but in a sense, it has to do everything with it, because this gives us the opportunity to look at what applications where IoT is needed. And then you can see clearly our reliance on technology going forward, because to do certain things, we have to do it very efficiently, because we will no longer have the men or the manpower to and the women to do all this work, right? So then if you look at this chart on the left side, ischemic heart diseases are the #1 cause of death in Sri Lanka. This is 2016 statistics, right, which has not changed for a decade. So what it means from IoT perspective is, why not monitor heart rate using devices, right? So there obviously there is a case where we can save lives. So that's the fundamental reason I wanted to put these statistics and then start from here, because this gives us the springboard to talk about the IoT applications. And then coming on to IoT applications, I will talk about 4 different IoT applications. Basically, our food production, then how we work, our health and well-being, and the environment we live in. So whatever these applications where the IoT comes is, IoT is for monitoring. And then you monitor this data, collect information, you apply analytics, use machine learning, blockchain, robotics, whatever. Then on the other end, fag end, you control certain actuators. So the IoT, in a sense, do a very important part. The monitoring and the control is done by the IoTs from sensors and actuators. And the other technologies like 5G and what I just mentioned come in between. So this is the general model, whatever the use case that you would be looking at. And then on our food production and basically the agriculture sector, domestic food needs and the plantation sector, the contribution of which is around 8% to Sri Lanka's GDP. But then again, we have not been globally competitive. If you take the plantation sector, and if you recently visited the factory, your grandfather might have had the same experience like you would have had, because nothing much has changed. They still use their colonial type equipment, use their labor forces and so on. And then from the earlier argument I presented, these companies will no longer be able to do that, right? Recently, I saw that cabinet has approved 1,000 rupees per worker, but then how you can go on doing that, right? If you don't bring in more money to the country. So these are fundamental questions that they have to answer. So in doing this, what you need to do is to have a total value chain transformation of what you do. And to do that, obviously, you need to use technology. And when you take the global, the internal food consumption, we need to do things more efficiently, because we will be using so much land. We have, being an island, we have limited land. And then unless you use technology, we won't be able to survive in future. And in this sector, there are a number of opportunities from irrigation to weather prediction, disease management. We have a certain experience in protected farming and using sensors and actuators to control the protected farms or the greenhouses. There can be a significant, notable increase in the yield. And drones can be used because you can collect information, and then you can use advanced processing. There is something called a hyperspectral image processing, where you can identify the diseases, the nutrient needs, and so on. And environment monitoring, if you now taking a soil sample and sending it for testing, and that testing body gives it back in, say, 2-3 weeks time, you can now have that's being monitored automatically. So similarly, I'll move on to the IoT front for the industrial applications as well. So here there are two critical requirements. One is ensuring business continuity, and then other one is ensuring operational excellence. Business continuity is in these pandemic times. You want to keep track of your operations, what's happening in your organization, ideally remotely, because you have to have less force, less labor, less people in the office premises. And then again, the cost pressure is always there because you need to continually reduce the cost to meet the targets, right? And then the IoT helps in this in two different ways. One is it directly enables you to monitor devices, the cyber physical systems, digital twins that Chatura talked about. And once you monitor them, the data you collect can be used in predictive maintenance and then bringing down the cost again. So I'm assuming that most of the people are from the BMS or the building management sector. And then if you take BMS as an example, traditional BMS, which you would put to a building, right? You can put it to a new building and it will come with wired connectivity. There won't be no problem, and the new systems will have on the cloud itself as well. But if you want to monitor all the buildings and then scale up, use low cost sensors, this is where IoT can play a bigger role, because you can have inexpensive sensors depending on your need and then scale them based on the requirement, right? That kind of flexibility might not have been there with the traditional BMS solutions. And then other things you can scale up. As Chatura mentioned, it's a platform. And then if you want to control your AC, depending on your, say you monitor your CCTV camera feed and know how many people are entering your premise. And based on that, you monitor, you control the temperature and humidity, right? If you want to do that, IoT provides you that capability inherently, right? And your teams, local teams, if there are software developers, they might be able to integrate these to the larger ecosystem. So that's the flexibility that IoT would bring into an industrial setting. And moving on to health, the acronym for health-related IoT devices are Internet of Medical Things, so IOMT. That is where you use you monitor medical devices and use this information collected to ensure your health and well-being. So here also, there are different segments, the on-body to in-home to community segment, and then you can monitor infrastructure in hospitals. And then because of this, the COVID-19 pandemic, this acceleration in technology in healthcare will continue to increase, right? And then coupled with our demographic, if you see that elderly population is increasing, more applications related to elderly care like fall detection and so on, that might become a reality. And then if you look at our statistics that earlier I showed you, it might feel that we are more or less going towards a country like Japan, right? Where they also have an aging population and so on. But we are a much poorer country. But then again, the difference here is our urban population will reap the rewards of all these things. But if you go to rural areas, it might not be the same. So you might not have the same facilities in our national hospital in some of the district or base hospitals in this country. So that's where the IoT can come in. You can have this medical devices, and the doctor and the specialists or the consultants, they can be in main hospitals, and then you can connect them via the devices, get your reports, and then give a better service to poorer people of this country. So in that sense, IoT and the technology in general is a great leveler to uplift the living standards of the people of this country. And then healthcare technologies. Now, the thing with IoT is because of the stack and the technology stack that Chatura presented, these technologies are readily available, and you no longer have to be a Fortune 500 company to invest in these kind of applications. Locally, there are some examples as well. You can have a startup, and that startup can try some of these things out. And we have been helping some of the startups as well. But that is where the world is going. And then some of these big, smaller startups get eaten up by bigger corporates. That's a different story. But it really, the IoT has and the technology stack has provided the opportunity to people, to individuals to grow. That was not the case 10, 20 years ago, because technocrats never had that opportunity. And then finally, moving on to the environment. This is a movie I saw on Netflix. I thought I would bring this in here as well. So this is David Attenborough speaking about his life and what he has seen in his lifetime, how man has destroyed the natural habitat, and how we have become a part of the nature rather than being part of the nature, right? And then how we need to undo that damage to make this a better living place for the people to live in. And then he's talking about these future cities, greener cities that I have put here. But in the very short term, we have other problems like urbanization has brought in certain problems that there are for us obvious to see, right? The environment deterioration, sanitation problems, traffic congestion, crime, and then in our lifetime, the traffic jams we have experienced, we have seen these waste dumps falling on people's heads, right? So things that should not have been experienced by previous generations, because it's things that have been created by us, right? So here also technology can play a pivotal role, particularly IoT, because there are a number of smart city applications that you can have, from road traffic to smart parking, public transport, utilities, waste management, and so on. So it's people will continue to engage in these applications, and they will bring it in, and then it's a matter of time where we'll have a better cities, better managed cities, right? And then in doing these applications, we have certain challenges as well. Before challenges, why IoT has been so prominent is there are certain global drivers, right? Because in China, they manufacture, sorry, in China, they manufacture sensors and actuators very cheaply. So it's available for everyone. And then these mobile companies have gone on and put their networks. So mobile networks are available. And then with Google, the AWS, the Microsofts, they have their cloud technologies, platforms, and so on. So everything has come together for us to create applications like this. So it's an ideal environment for anyone or any startup, any company to go for IoT applications. But then again, the unique challenges we face are still sometimes it might be costly, right? You might be comparing a person collecting energy information, going from an energy meter to energy meter, to having a IoT implementation, right? So sometimes you might feel that it's worth it still to have that person rather than go for IoT, right? And then that is what you need to consider. Customization, because every enterprise or industrial IoT requirement is different. That's based on our experience, because then you need to adapt to those situations. You can't just get a cloud solution and then put it there, have it as a software as a solution kind of a product and use it, because individual enterprise requirements are different, because that's the way people do things. And the configuration, what I meant first from configuration is different technologies, because different technologies, project management, privacy related issues, policies, right? Because once everything is connected, you need to manage all these devices, right? And ensure that the privacy is there, because you will have another set of problems associated with IoT, which you wouldn't have unless these devices were physically disconnected. So those are some unique challenges we would be experiencing. And how we can overcome these challenges, I put some pointers based on our experience as well on the field. Because if you take cost and affordability, one way is to, if you want to reduce the cost, is to look at the whole value chain rather than looking at the entire product. You can maybe reduce from the sensors, reduce from the platform, have a smaller scale application, right? And then you can look at the total cost of ownership. Say in 5 years time, what's the total cost of having a person to having a IoT implementation. And you can go for SaaS models, turnkey projects, and you can play around with sensors as well. You might sometimes, depending on the business criticality, sometimes you can use lower grade sensors, right? And if they are not very important, you can just throw them out if one breaks, because they are so cheap, right? And then you can consider the overall operational and management strategy of your organization as well. Because what IoT enables is when everything is connected and information is in one place, your monitoring team and your operation teams can be consolidated, right? There was a time when you have a system which monitors certain set of applications and you have a team dedicated for that. Likewise, you had different silos based on the system, right? So now you can think of a solution where everything is monitored by a central team, and you can even outsource that central monitoring functionality. So those are the things that you can do from cost-wise. And sorry. And on customization and adaptability, I just told you that IoT projects from client to client is very different. So you might, it's best to work with some partner who is very reliable and who you can trust, and that who you can provide you service quality and the SLAs, right? Because the technology is available, the analytics and everything for us to do our own thing. So if you own the data set rather than some foreign company somewhere collecting all your information, you might in future use this information to come up with some other machine learning algorithm or something to improve, right? Improve your operations and so on. So that's one way of looking at things. And of course, you need to get on the configuration side, you might need to get help from the experts on how we manage security, privacy, and then have a governance policy for all IoT devices, right? So, and then avoid technology fragmentation, because if you get too taken up with technology and what technology to use and so on, you might lose the whole point in achieving the efficiencies that IoT promises. So you need to manage all these aspects as well. And then moving on to business models, what is great about IoT is earlier also I spoke how these companies are pivoting business models, right? Similarly, on the IIoT side, the industrial IoT front, you can have different business models as well. For example, it can be revenue sharing, right? Where the additional revenue you make from IoT implementation, like airlines giving the customers a tracker, right? And then charging for it and sharing a piece of that charge with the IoT vendor, right? That can be a revenue share model. And then the cost saving. So if you put monitor energy, a company might come and tell you, look, we will monitor your energy consumption, and then we'll help you in reducing the cost of your energy. Give us a saving of the cost, the share of the cost saving. So that's a classic case of that business model. And then product sharing, the car rentals, right? You need not own a car, but from place you go, you can rent a car, right? And then use different cars depending on your need. Product as a service, because here you will not own the product, but you just lease it out to the customer, and the customer pays you a recurring fee, a recurring monthly fee. Similarly, you can use a SaaS model as well, because you can pay upfront and own the product, and then the software on the cloud, you can pay a monthly fee. That is something that professionally we have been trying out as well. And then performance as a product, like a aircraft, this is something being used by Rolls-Royce, where they guarantee a certain performance and then monitor this performance and then ensure that performance is there for them to get paid, right? So that is very highly technical use cases. But the salient point is depending on the use case, depending on the application, you can try out different scenarios with IoT, because it's no longer a transactional type of business model like in the last case, because you used to buy a system from somebody and then use it and then pay maintenance fees, right? So that is what we are all familiar with, right? But it's no longer the case with IoT, because there'll be a lot of people, vendors, and everyone would have their own models, and it might be beneficial for engineers as well to look at these models and then decide what's the appropriate model would be. Then in the immediate future, what we have seen IoT doing to the business world is on business digital transformation front, because many companies nowadays are thinking or looking at transforming their businesses into digital businesses, right? Because to get more from their physical assets. So IoT is connecting your physical assets and getting information from your physical assets. So, and doing so, companies, if you believe the statistics, has certain profitability increases, market value increases, and so on, right? Different people will quote different things, but generally what it would lead to. And then the financial performance has increased as well, and then together with higher customer and employee satisfaction, right? If you, in the table below is where you have in segments that IoT be mostly utilized, or utilities being one of the main cases, then the government, the building automation, the physical security, and so on, right? So it gives you an indication of in which segments people have been using more IoT stuff. And then along with this business digital transformation, one important factor that you need to take into consideration is the COVID situation. Because if you look at these statistics on the left hand side of the table, it says on the dark blue graphs how people have adopted digital channels during the COVID period, right? There is a substantial increase in people or the customers interactions from digital media, right? With the COVID going off, this might taper down, but some of it might remain, right? So that and there's one other thing now. This the adoption has been, if you consider the Asia Pacific region, the 4 years of digital adoption has happened in just 1 year, right? Because if the pandemic wasn't there, people wouldn't have been doing it. It would take 4 years to do these things, right? So similarly, on the right-hand side, what you have is how people have adopted technology more during these times. So if you look at the smaller prints, increased use of advanced technologies in operation, previous to pandemic, it might be 672 days. That is, you take 1.5 years or close to 2 years to do a IoT project or a modernization project, right? But now people have done that in 26.5 days, right? That's closer to months' time. So it is similar to what we have seen in seen locally as well. People asking us to do whether we can do certain automation in a rapid period of time, right? So this is the real impact of this pandemic, together with the business digital transformation initiatives to IoT. So it's a kind of a pivoting point as well from an industry perspective. We might not be the particularly in Western countries and developed nations, these might be more adopted than here in Sri Lanka, because we have certain other pressures as well. But then again, in general, this is where the world is leading to. And then how we can, my last slide, is to some thought on how we can make this a reality, right? It's a collab. What I feel is it's a collaboration of a lot of people and the partnerships and working together to create a future we want. Because the government would of course have to set the policy and the agenda and the strategies, right? Because if you look at and all these health care, agriculture, smart cities, there is so much that private organizations can do. They can certainly enable things, but some vision needs to be there, and you can get the involvement of startups as well. Very recently, I saw that it has been made possible for startups to bid for government tenders as well. So people are thinking about this collaboration and partnerships, and then professionals they need to support, and then you need domain knowledge expertise as well, because if you take an agri project, certain domain knowledge on agriculture might not be there with the engineer or the tech guy, right? Similarly on healthcare. So it's always a collaboration with the farmers or the agriculture specialist or the doctors, right? And then you need to buy people into a common vision to get everything rolling on. So with that, I will conclude the presentation. And thank you very much. And extremely sorry if there has been any disturbances. And you can probably ask any question from myself and Chatura if you are interested in the subject. And thank you very much.
Yeah, thank you very much, Mr. Chatura and Mr. Chamila, for your informative presentation. Now it's time for the Q&A session. We have got several questions through the chat option, and I will forward them to users. So question one is, can you explain usage of blockchain and edge computing?
Yeah, Chamila, shall I answer that?
Yes.
Yeah. So I think as we mentioned in our initial presentation, so blockchain plays a wider role in this IR4.0 enablement. So if you look at blockchain, the theory behind blockchain is mainly focusing on DLP, where you call DLP as distributed ledger protocol. So blockchain, the use cases are endless. Like mainly now you might, the buzzword of blockchain is mainly from this financial currency perspective, but the usage of blockchain is kind of open with multiple opportunities. So one such example is the smart contracts, right? So if you want to track smart contracts in terms of different use cases, so when you hear the word of smart contract, you might think it's a kind of a legal something to work with, but it's not like that. Not only for that, so you can use blockchain for food related use cases, where you can identify the authenticity of this food. Now, in some case studies of most of the developed countries, they use blockchain-based verifiable credentials to identify the authenticity of the winery or the end product based on this blockchain-based smart contracts. And on the other side, blockchain can be deployed for smart supply chain. So you can get kind of just-in-time ecosystem to track your suppliers and your whatever the bill of materials, whether you will reach it on time without are there any delays. And through Internet of Things, together with blockchain, you can analyze the behavior of those things. And even if you take blockchain, if you are interested in terms of developing a blockchain related logic, there are a lot of open source platforms. So name to few, if you want me to name few, this Hyperledger Fabric is one such platform, and there's another platform called IoT. So those platforms will support multitude of opportunities. On top of that, even Google and Amazon is providing such platforms over their cloud services. And if you look at the edge computing, I think edge computing will be another killer technology change, which is going to happen with the introduction of 5G. So as we discussed in my slides previously, 5G will enable that 4 slicers together with EMBB, URLCC, and MMTC to support this edge computing. So what do you mean by edge computing is rather than you process everything at the back end, you transfer some of the processing capabilities next to the machine. So you can have a hybrid kind of computational algorithm. So some resources that you will do the processing at the edge, while some resources that you do the processing at the cloud. So 5G kind of next generation technologies will enable such edge computing cases, especially for this video communication related analytical use cases. Because as we discussed earlier, because the high definition video feeds need lot of traffic to transmit to the backend, even though with 5G you can create a kind of a edge process algorithm to get this some of the video feed related algorithms to analyze the content, and you can use cloud based GPU or the graphics processing capabilities at the cloud level. So hence that you can enable power of hybrid cloud, where you have one portion at the cloud infrastructure and one portion at the edge infrastructure. So those are the powers of edge computing in time to come that we are going to experience.
Thank you very much, Mr. Chatura. Our question number 2 is, what kind of IoT options are available in smart cities and how they apply to make the city smart?
Right. So Shamil, I think you covered smart cities. Maybe you can take that.
I will take that because just like I presented, there are different smart city applications, right? So it can be your smart parking, right? It can be using in the light poles. You can have certain monitoring. You monitor the environment, the status CO2 levels, and so on, right? And then you can have these digital signboards on the light poles, right? And you can have these smart bins that are connected, that will give you information when the bin is filled. You can come and collect the bins, right? So likewise, there are many different fields, and if you take the best way to start is to look at what a municipality is doing, right? They'll be doing certain services to the citizens or of that smart city, right? And then whether you can connect those services and thereby come up with certain applications. So if you can look at in that sense, right, you will be able to come up with your own applications for smart cities rather than looking at internet and see, these are the smart city applications. Because that's the kind of way I think people should think when coming up with different applications. Because we are also doing some innovation functionality in our organization as well. So that is fundamental in everyone to come up with a different application. So if you can come up with something like that nobody has thought of, then you might have a successful venture going on, right? So think of that way, and then you'll think of many different smart city applications.
Thank you, Mr. Chamila. Our third question is, how IoT can work with existing automation systems in buildings?
So let me answer that. I think since this forum is mainly focusing on this this kind of automation functionality, I think there's a capability of IoT to do different orchestrated capabilities, especially for this building management infrastructure. So BMS is one such capability that you can give full power of IoT with all these other IR4.0 enablers. So if you get the sensory capabilities of a conventional building management gateway, if you have this Modbus kind of communication capabilities, then this existing BMS gateway can be hooked to an IoT cloud. So even though this current BMS functionality limits some of the functionalities of next generation IoT and IR4.0 enablers, by extending this existing BMS to a platform like what we've discussed during our slide, will enable or ramp up the capabilities of IR4.0. The other way is you can the sensors or the apparatus can be directly connected to the platform as well. So in some scenarios now, let's say if you have a kind of existing building with conventional system of central AC. And if it does not have any communication capability, either serial or Modbus, there's another way of doing things, so that we install few number of sensors and actuators, and you get the pulse of trigger as we discussed in the the network abstraction way. And even without investing for another on-prem BMS, you can get the functionality of BMS without changing our existing infrastructure to extend to our IoT platform at cloud. So those are the capabilities of different ways of integrating IoT and 4IR into this existing BMS domain.
Yeah. Add to what Chatura just explained, two fundamental things. One is you need to look at whether southbound APIs are available from your BMS. That is, you can directly connect devices to your existing BMS. Then other thing is from a different application, whether you can get information. So your devices might be sending to information to a different application, but from a BMS front, you have APIs to get that information. So what we call platform to platform integration. So those are the two fundamental things that you need to look into.
Thank you, sir. Our next question is, what are the available sources for developing digital twin of a building?
Jamila, you want to take that? Or? Yeah, let me explain. So if you take sources, it's endless, right? So if you want to get a kind of a previously discussed scenario of BMS, digital twin is just a kind of a the representation interface. So if you get this feed of data from your existing BMS, or the way that we discussed in our previous whatever the question, if you get that information to your IoT cloud, it's a matter of the presentation and analytical layer to do that meaningful whatever the grabbed information to the presentation. So digital twin is not, though it makes a kind of a buzzword these days, digital twin is a kind of a simple replication of the state at the remote end in a kind of a virtual fashion, but with enhanced flavor of artificial intelligence, machine learning, and big data analytics. So if you look at this the capabilities of GCP or Google Cloud Platform, if you go and browse what exactly the offerings that Google give, you can get an understanding of how these capabilities of TensorFlow is the artificial intelligence and machine learning stack offered by Google. And also Amazon AWS gives all these capabilities in a kind of a SaaS and cloud offering. So with all these additional piece of analytics capabilities, with the existing data coming from existing BMS, you can develop kind of digital twin local. That is why I mentioned that with all these technology enablers, we don't need to go and ask developed nations to come with their offerings to cater to our local emerging market communities. So this is the time that we as engineers, we should ignite with our knowledge and our capability, and we should contribute towards the upliftment of development of our country with our internal resources. So that is the power of IR4.0 in terms of bridging these technologies in these emerging markets.
Yeah, adding on to Chatura, it's all on the software development layer. So if you can do 3D modeling and animations, right? That's basically your digital twin, and you feed that with the real-time information you get from sensors. And then the nice videos you see out there are augmented reality technology. So you view that model in augmented reality view. You can have your nice digital twin there. So that's how you go and do it. So IoT is fundamental to getting the information, and then you play with the software to create your own twin.
Thank you. Our next question is this is again from the digital twin, and question is digital twin can be applicable in maritime domain, such as let's take the engine of the ship. So will this digital twin will able to give alerts of the condition of the system?
Yeah, I think that is again related to previous answer we gave. So it's application agnostic. Digital twin just a kind of a layer which interfaces with the existing data, and it present in a kind of a very different meaningful way. So whether it's maritime or whether it's civil engineering or whether it's communication engineering, it does not matter. So it's application agnostic and use case agnostic. So I think if you browse this General Electric website, they might have a lot of use cases with their motors and electric machinery, how they have developed this digital twin kind of concept. So with that, you can identify any anomalies or any kind of sensory inputs even coming from that maritime engines and replicate them in a 3D model to mimic the twin functionality, and then you can get that kind of insightful information without having the physical presence. So hope I answered that question.
Okay, thank you, sir. Our next question is how Sri Lanka's position in terms of using IoT compared to other Asian countries?
I'm not really aware whether anyone has done any study or research on that. There probably might be, but it's nothing. It's not something
But
that.
let me add on. As I mentioned, I think we being an emerging market with all these technologies, I think we should not have any step back kind of this thing. So we should bring our all the resources together, and we should leapfrog our capabilities to a level of the digital, almost already digitalized or developed nations kind of a state. So I know that there are some initiatives from the policy making standpoint in terms of supporting this government digitization and then the private sector digitization, and all these things are happening. And that is why I mentioned even this Privacy Act and data policies and all these things are being drafted in parallel. So that gives a pulse of a trigger that we also embrace these technological advancements in our country as well. But I think what we need to infuse is the time to go to market. So we should make, as I mentioned in my presentation earlier, we should sense all these the sensory mechanisms. Through our sensory mechanisms, we should identify this pulse of different waves or different technologies and act very fast, because the competitive advantage will not last for very long. So you will need to embrace that within a very pulse of a trigger, and then that will convert a kind of a possible positive business case to drive these use case. So
okay, thank you, sir. Our next question is internet strength enough to cater this IoT platform in Sri Lanka?
yeah, definitely. I think internet, because this IoT mostly, other than video surveillance related information, IoT sends very minute amount of data. So if you look at sending a SMS, it sends kind of kilobyte amount of data. So likewise, for most of the IoT operations, you don't need massive bandwidth other than this video related analytics kind of use cases. So the current internet and current infrastructure is almost sufficient if we have any kind of IoT related use cases to ignite. But on top of that, with 5G, as mentioned, we discussed earlier, it will add color and it will add next generation capabilities, so that even the advanced use cases is possible. So even if you want to do video analytics related IoT use cases, it will be available in very few months down the line with the commercial deployments of 5G networks.
Yeah, adding on to Chatura, with 5G, you can have different virtual network, what you call virtual private networks or campus networks. So rather than being affected by internet traffic, you can have your own network. So if you have serious industrial automation applications and you need certain latency requirements, that technology will be available for that sort of applications as well. So that is a definite reality in future.
Thank you very much. Our next question is IOP users different OSI model as opposed to standard OSI 7-layer architecture?
No, that is almost aligned with OSI 7 layer architecture, but there are different flavors of protocols. If you take the data link layer and the layers above that and the session layer and the application layer, there are minute variances, but the overarching the standard OSI 7 layers of definition applies everywhere. So
Thank you, sir. Our last question is profit generating IoT use cases are very rare in the market to keep running business with a few engineers. Is it BCOs this market is not, is it because this market is not really ready for IoT related solutions? For an example, Sri Lanka labor is cheap.
Kamil, you want to answer that?
Yeah, that's one of the points I wanted to make during the presentation as well. But in certain cases, it might seem that labor is cheap, but you have to consider the impact for a period of time, right? Going forward, whether labor will be cheap, right? That's why I wanted to put this population statistics and so on, and make a point that ultimately at some point in time, we'll have to embrace this technology. Not right now, maybe for some of the applications, but you need to consider a total cost of ownership for a period of time. So it will depend on the application. So you cannot, I don't think you cannot generalize that, right? So for a classic example would be, say, our electrician, the meter readers, whether they would lose their job if we are to automate the electricity meter reading, right? But then again, the government is considering that. I saw recently in newspapers that they are seriously thinking about doing that, right? Because in the long run, if you have few of the population, they might as well be doing productive things rather than doing things which a machine is very much capable of doing, right? So we are using our labor effectively. So I think that's the way we should think, because human resource is the ultimate resource, right? And they should be doing higher level things rather than doing these kind of things, right? So if you think of that in that way and take the total cost into the consideration, maybe you will think that some of these cases is definitely viable. So that's my take on it.
And also you must, just to add on to that point, I think you must augment your proposal of offering, not only from one perspective. So maybe human resource might be cheaper, so how business case might be not successful, but from a different angle, you must show that the analytical capabilities for decision making, and in terms of cost savings, in terms of applying preventive maintenance. So all these capabilities are on top of whatever the labor resource. When you bundle that offerings together, you might be able to convince your customer with a very positive business case. So those are the innovative business models that you must carve out during this era of OIR and IoT enabled.
Thank you, sir. Our last question through the chat option is, who are the IoT service providers in Sri Lanka?
Yeah, I think it's a bit of a sensitive question to answer in a public forum like this, but there are different service providers, including most of the telecommunication service providers are also very much geared to do that. So likewise, even there are a lot of startups has really boomed even during this COVID era, as well as even beyond before that. So if you browse the internet, I think definitely based on your requirement, you might be able to find. So that is why I said, though Sri Lanka is an emerging market, there is talent inside Sri Lanka, people who are doing the developed market level products within our country. So hence that we must believe in that, and we must support their whatever the contributions.
Yeah, thank you very much. With that, we have come up with the end of the race questions we got through the chat, and now it is time to go for raise hand questions, and we can have maximum 1 or 2 questions from the audience. I think Mr. Jagat is waiting here, Mr. Jagatlal Vikramasekara. Mr. Jagat, you can unmute your mic and ask the questions.
Thank you very much. Thank you very much, Chatur and Chamila, for the wonderful presentation. I have few questions, especially as a profession who are also into building automation system. I have this few questions, especially in normal automation system, you get these sensors and actuators layer at the very bottom, and then the controllers layer, where you get all the logics and all the control options are residing, and then the HMI layer at the top. Now, when this new IoT situation comes, or this application comes in, how it is fitting into this particular existing model and which component will be changing? That is my first question. And the second question is, now usually when it's come to a normal building automation system, the price factor varies based on the number of points that we are using. You know, higher the number of points, higher the temperature monitoring and things like that. Obviously, the number is the price factor will go up. But when it comes to IoT, on what parameter this pricing factor will depend? Those are the two questions I have. Thank you.
I think, thank you, Engineer Lal. I think one of my very good friends. So let me answer your first question, and I might give Chamila to answer the second one. I think your first question was mainly on this, how the best fit of this automation system architecture in this IoT world. So as I mentioned earlier, so we have two options. So one is this platform to platform integration, or device to platform integration. So if your existing automation architecture or the existing automation devices support some level of capability in terms of creating such automation, then the simple option is that we get the information fed from the gateway of your existing automation gateway. So either it can be from RS through 232 or 486 kind of a protocol, or X25 or Modbus, or you name it. If any of such protocol stacks are there, then different IoT platforms can develop service brokers, even custom defined service brokers to hear these proprietary protocols as well as standardized protocols. So with that, it will create a link between your existing gateway and with the next generation IoT cloud through a kind of a platform to platform architecture. And the other option is, if your gateways are lacking some of the interconnectivity capabilities, you can have that the proxy gateway devices in between your existing gateway and with your existing sensors. And so while feeding the existing information to your existing gateways, we can get a carbon copy of that data feed traverse to IoT, next generation IoT platforms as well. So you can make a decision whether to stop sending that information to your existing system, because the value addition that you are gaining from the new system is greater. Then likewise, you can benchmark, and then you can fade out your deployment architectures based on your preference. So IoT enables all these permutation and combinations of different automation capabilities. So one example, just to highlight that in the plantation sector, I think we are having that years old machinery, right, during 1980s, 1890s. So even that machinery can be onboarded to IoT with the current 4IR technology enabled. So if those things can be done, I think definitely the flexibility of permutation of different capabilities are there to have a hook to existing automation systems to our IoT ecosystem. Hope I answered all your question, and I will give the forum to Chamila so that you can answer.
Let me answer the second question, because there will always be a cost associated with the devices. So that will be a variable cost, because the device itself has a cost, and then the network connectivity itself, the data being transmitted and the data collected on behalf of that device, there is always a cost associated. But then again, there might be different vendors who provide different business models, right? Like I said before, it might be they are monitoring your power consumption and say, based on these analyses, we will reduce your cost by this amount, and please pay us a portion of this cost saving to us as a part of the solution cost, right? There might be a minimum guarantee involved, but there might be people, I definitely know of vendors who offer that kind of propositions to customers, right? So the customer in this sense has the option to see different possibilities or different variations on how he can afford this solution, right? And depending on his economic situation, he might go for the most affordable use case, right? So IoT gives that variability or that flexibility for you to come up with your own business model to your end customer. So that's between you and the end customer on how you plan to do it. It can be a set of.
Sorry for disturbing, Jamila. I didn't. My question was about the cost factor. On what ground the cost will be increased? Business model is something else. It's how you recover that cost. My question is whether it's due to you are buying a software. Now, when you are buying the software, the price of the software will vary on this factor, and then you might also say that okay, we need to deploy a couple of programmers. So that's another cost factor. So that's the question I want to really impose here. It's not the business model basically. On what are the parameters which increase or decrease the cost of implementing a IoT for your building?
To answer that question, right? It will have to go back to the offering that vendor gives. For example, maybe a basic monitoring functionality, like you are just monitoring and giving information, that vendor might give at a certain cost, right? But then if you're using that information to have analytical information, right? So predict your machine downtime or predict your bill, right? And then that sort of advanced functionality, they might charge a different cost, right? So that functionality based costing might be there, right? So those might be the cost drivers, right? And then again, if you go back down to the sensor level, right? There might be cheap sensors available. If you take electronics, you can have the same sensor from China or USA that do at two different prices, right? And then depending on your application, you might see this is one way of you can get down the cost, right? It might not be worthwhile to use a very expensive sensor, right? Then you can go for a rather cheap one, but it will last for say X number of years compared to that expensive sensor, right? Likewise, and then the networking cost will also add, and then the people will also consider that onto the solution itself most of the time, and you don't have to basically pay for SIM, right? SIM and the data, because that SIM and the data cost might be absorbed to the entire solution. So likewise, you'll have to look at the different pieces in this ecosystem and see where the cost is, right? And it depends on the user scenario. So my Chatura might be able to add something onto that as well if I haven't answered satisfactorily. But that's my take on it.
Yeah, I think just to add on to that, I think we can work in terms of low-cost devices. Now, if you look at kind of BMS from Schneider, their gateway cost will be very high, right? But the same gateway functionality that you can develop locally as well with kind of Modbus kind of communication stack built in. So those are the opportunities that we need to benchmark and decide whether some of the capabilities of these automation pieces, whether we can locally manufacture. Why I'm saying that is that we have eyewitnessed that capabilities of that, and we have done some research and development, and we have products that we've developed to cater this emerging market business cases to drive with these low-cost devices. With collaboration, innovation collaboration opportunities with University of Moratuwa research laboratories, that we have developed some IoT gateway devices support and bridge this kind of anchor the problems that you mentioned. So that is another opportunity that we can identify, because most of the developed market price points of making these automation gateways might not be positive, as you correctly mentioned, to serve this emerging market business requirements.
Thank you, Mr. Jadura. Thank you, Mr. Jamila. And our last raise hand questions, you can ask. The name is indicating as iPad. I don't know whether the gentleman.
I'm Jayant Ranatunga.
Yeah, Mr. Jayant, you can raise your question.
Yeah, my question, it's not a question, it's a comment about this myth about cheap labor. Short story with you. This, explain it very well. Some decades back, not now, China was building a earth dam, and there were some World Bank experts who were there, and Chinese labor, large number of labor, were using wheelbarrows and shovels to build the dam. So the World Bank experts said, why don't we use bulldozers, dozers, front-end loaders and things like that? Then these people said, I knew that you will ask this question, but what will happen to this labor? We have so much of cheap labor and we have to make use of it. Then he said, in that case, why not you replace the shovel with a spoon? You can employ more labor. Thank you.
Thank you very much. Thank you very much, sir. And that's the end of our Q&A session. I will hand over for the proceedings to Chairman of the Building Services Engineer Sectional Committee, Engineer Prasanna Narangoda. Over to you, sir. Thank you.
Thank you, Engineer Sean. Thank you very much. So lastly, we heard Engineer Jayant Ranatunga's very senior engineer of ISL. Thank you very much, sir, for your participation. With all your permission, I am taking only 1 minute before the vote of thanks. That is just to add on something, the disturbance coming from one mic, kindly keep it mute. So I'm taking only 1 minute to highlight one point, which is highlighted by Engineer Chatura during his presentation. That is about that the use of IoT can make this developing this stage to develop this stage one day. So I really agree with that point, because if you use this IoT properly for agricultural sector and the other private and business management, as well as and to have connected cities everywhere in the country with proper traffic management, will attract more foreigners into the country. So there would be many opportunities that we can use this IoT to the development of the country. Otherwise, our past is already gone. This is only the way that we can move, climb on this ladder to go up to the developed stage, at least by 2030 or somewhere there. We keep good hopes. And also I really appreciate, and also I'm happy to have this kind of very capable engineers with us in our country, who has not left the country so far. So we really like to, we are proud to have this type of people with us. So I'm sure our decision makers in the country, the leaders who are leading this country, will use these capabilities of these engineers and develop these countries with the help of this type of technological advancement in the country in future. So thank you very much. With this, I'm calling upon Engineer Malaka to give the vote of thanks. Engineer Malaka, please.
Hi, good evening, ladies and gentlemen. This is Malaka Samaratna from Building Services Engineering Sectional Committee, and let's move towards the final note of the day. We were listening to a really interesting lecture today with the participation of more than 110 members in the audience. Being engineers, we all should alert about multitude of new technologies such as cloud computing, artificial intelligence, machine learning, and 5G mobile networks in all our sectors to give optimum output to our stakeholders, just as we targeted through this lecture. I am pretty assured that the lecture today served us in great way to enhance our knowledge. Moreover, it is being a great pleasure to us to connect with Engineer Chatura Piris and Engineer Chamila Vijayawardena, our two resource persons of the day, who are well updated with the role of IoT and its contribution on fourth industrial revolution. Dear both, thank you very much for the dedicating your valuable time for the benefit of this interested audience. This event wouldn't be success if there wasn't an interactive audience like you all. Raising your valuable questions and sharing the ideas you had help others to learn the content of further extent. Thank you very much everyone for the participation today.